Hello, welcome to my webinar on working with cladding in advanced steel. We're not going to keep you a huge amount of time today, but this is a subject that often causes a bit of confusion, so we thought it'd be nice to clarify how the tools work. So who am I? Well, my name is Alec Giles. I'm a structures consultant at Graitec, and I'm also an Autodesk Expert Elite. I was originally trained as a mechanical design engineer around 30 years ago, and I was a member of the Institution of Engineering Designers until 2010. I spent around 10 years designing machinery, primarily for the steel and aluminium industries, heavy machinery. And then I moved sideways to become the CAD manager at the company I was in. I was providing training and user support for around 200 users in that company of AutoCAD, AutoCAD Mechanical, Inventor, and Solid Edge. But then I moved to Graitec in February 2010, so I've been at Graitec almost 11 years. And since then I've focused up 100% solely on advanced steel, doing support, training, sales demos, consultancy, etc. I don't touch any other software at all. So overall, I have around 20 years experience in providing support and training. Why should you choose Graitec as your partner in business? Well, we think we're unique in being able to offer services and products that support the entire life cycle of your products. So we like to split that into 4 areas. First, we have Graitec Create, where you create your designs of your products using Autodesk tools, and those are enhanced with Graitec Power Packs. We have Power Packs for Advanced Steel, Revit, Inventor, and Volt. And they add extra tools on top of the standard in-the-box tools. Once you've got your basic design, you need to check it's going to really work. So you can use Graitec Simulate, where you have state-of-the-art simulation tools, and you can test and analyze your structures to make sure they're going to really work in the real world with our market-leading tools. Once you've got your finished design, you need to make it. So Graitec Fabricate covers tools that will manage your entire workshop. So that tool can manage the product flow through the workshop. It can control your scheduling of your human resources, like your welders and your fabricators, as well as sending the right NC files to the right machine tools to interpret those NC files, get those tools doing the right jobs at the right time, and monitoring the status of every component in your workshop. All of that stuff takes an awful lot of data and an awful lot of files. So the last step is Graitec Manage, where we have software available there and services to manage all of your work in progress data. That's all the files and data and intellectual property within your company, right up to the point where it goes past outside your company to an external data environment. This webinar is one of the regular webinars we do. We're constantly doing webinars on each of the main products, and you can find a content center for each of the main areas there. There's an advanced steel content center. If you click on the link here, you will be taken to a page that has a list of all our previous webinars. Every webinar we do is recorded, and there are over 50 currently available on the Advanced Steel Content Center, and you can watch any of them on demand. You can download these slides as a handout. If you go to the Go to Webinar panel on the right hand side, there's a handout section. If you download the handout, these links will be live and active. But we also do a lot more than just webinars. So first of all, we have the Content Center with over 50 webinars, approaching 45, 50 hours of content there you can watch. But we also have our Advanced Steel blogs. We regularly post tips and tricks and ideas and thoughts on blogs site. Just for Advanced Steel, we have over 100 blogs now on that site, and each one is a small bite-sized tip or trick you might find interesting and useful. Some really important information in some of those blogs, how to back up your data, share it with other users, and so on. We do regular conferences and we do regular user days. So did you miss any of those? Did you get our user day this year if you're a UK customer? Did you see the Graitec BIM Up conference last year or this year? If you missed it and you are a Graitec customer, log into the Graitec Advantage site, and videos of all our presentations are available on that Graitec Advantage site, so you can still catch up on anything you may have missed. And there's at least 30 hours worth of content for Advanced Steel there. And if you're in the Graitec UK and you've got support, then you are entitled to have the Graitec Advanced Steel Power Pack with no additional cost. If you're in other countries, please contact your nearest office of Graitec and work out what's available to you there. And as we've said earlier, the Power Pack is lots of extra tools for advanced steel beyond what's in the box, some extra bells and whistles. Very useful, some of those tools, to automate and simplify some common tasks. Moving on to this particular webinar, what's we're all about today? Well, many structures, such as industrial units, classically are covered with cladding sheets. Just to be clear and to define it for our purposes, we're talking about shaped sheets of material, usually in long strips, to cover a surface of a building, and they interlock with each other along the edges. We're not talking about fixed size panels that interlock on all four sides. That can't be covered with the macros or special tools in advance, so you'd have to model those manually. These are long sheets that interlock down the edges. Advanced steel includes basic tools and macros for modeling this such cladding, but many people do find these tools a little bit confusing, and I can understand why. So I'm going to try and demystify what's going on with those so you can make the most of them. Therefore, I'm going to show you how to use those basic cladding tools to create an area of cladding on your structure, how to make more interesting shapes, not just rectangles. I'm going to explain some of the basic options in the macro. There's a fairly limited range of cladding sheets in the system to begin with, so how do you define your own cladding sheets from your local supplier or your preferred supplier? And how about getting the cladding on the drawings as well? So the basic steps then for creating any cladding in your model. Now, to create any cladding area, Advanced Steel has a set of 3 commands that work together, and you have to follow the same basic steps each time. So if it's a simple rectangular area, you can use the define cladding area command, and just directly to define the area. Then you can define any openings in that area, and then that's the second command, and then you use the create cladding command to actually make the sheets filling up the area. If it's not a rectangle, it's a little bit more care required. First of all, you would draw the shapes you require. These shapes need to be closed polylines. Polylines are a standard AutoCAD function. You can find lots of help about them online. You need closed polylines for the shapes, for the area itself, and for the openings if they're not rectangles. Then you use the define cladding area tool to convert that polyline into an area. And you always say yes. It's important you always say yes to delete the polyline. You repeat that with the openings, so you use the define openings tool, select those polylines, and again you always say yes to delete the polylines. And then you can use the create cladding tool to create that area, fill it with sheets. So let's see that in action then. Let's have a look. So here we are. First of all, we're just going to go to the home ribbon, and in the extended modeling panel, here you go, this little column here are the 3 commands: define cladding area, define cladding opening, and create cladding. So first of all, let's do a rectangular area. We're just going to use the define area. And the first question is, do you want to select supporting beams? I'm going to say no on this first instance. And then I'm going to say I want a rectangular area, and just draw a rectangle. If I want any openings, then I'm going to go to define cladding opening. Obviously you can skip this if you don't need any. Again, I'm just going to say it's rectangular. Now the next click is not to draw the opening, it's to pick the area that the opening applies to. So you have to pick that outside area. Having picked that area, you only get one shot at that. Now I can draw the rectangles for my openings or my windows. So there's a rectangle, that would be my window. And then finally, having defined the area and the opening, I go to create claddings. Just click on the area, and then there you go. There's your cladding with the hole as defined. You can see it's all individual sheets of any length. I'm going to delete that. Let's do something a little bit more interesting. So I'm going to do a non-rectangular one. Now, first I'm going to draw a beam, and just put that in on the top middle. So here's the beam. I'm going to use this as a supporting beam this time. So when I do define cladding area, I'm just going to do supporting beam. I'm going to say yes. This time, show you what happens when you use a supporting beam. That's the beam I want to use. And then I'm going to just say it's a rectangular shape again. Draw the shape. I'm not going to bother with anything too fancy. Put in a quick opening, rectangular. Remember to click the area first and then draw the opening. And now create cladding. There you go. That cladding's going the wrong way at the moment, so one of the options in the box on section properties, the cladding properties, change it from vertical to horizontal or the other way around to make it go the other way. That's better. But what you can see now is where I've got the supporting beam, it overlaps the sheets. So you can see the two sheets there, the length is overlapping. You can control how much they overlap on the overlapping page in the properties box. So when you have a supporting beam, they overlap like that, the idea being that you would screw through both sheets onto the supporting beam. You could set the overlap to 0, so if you've got a thick composite panel and they don't overlap, you set the overlap to 0 and they would meet at the center line or the system line of the supporting beam. Okay, so let's come into our model, familiar model to everybody. And I've drawn some shapes in here. I can see that first shape is a polyline, more interesting shape. And these are just rectangles, but again, they're ready drawn rectangles, so they're all actually polylines. They're going to be the openings. You can see they're all for our polylines. So we're going to do a more interesting shape this time. So define cladding area. And this time supporting beam, I'm not going to use those this time. You've seen what that does. I'm going to say it's, if I don't want a rectangle, I'm going to say from polyline, which I obviously have to have already drawn. I pick that polyline and it will ask me, do you want to delete it? And I always say yes. If you say no, you'll have two objects on top of each other and you'll never pick the right one again. So always say yes, so you're left with just the area. So it did delete the polyline. What you can see now is an area object. I'm going to define the openings again. I'm going to say from polyline. And you have to pick the area first, remember. You would expect to go and pick the polylines, but you have to pick the area first. Now pick the polyline. You can pick multiple openings at once, so I'm going to pick all 3 polylines for the openings at once. It's no problem. Do you want to delete them? Yes, absolutely. Always say yes to delete them. So all you can see now are areas. And now I use the create claddings. Pick on the outside area again, and it covers it. But that's not matching my shape. That's just a rectangle. What's going on here then? Well, these are where the options in the box come in. So first of all, we can choose different types of cladding on the section properties. You've got lots of different things here to play with. But the may or may not include the one you want. Then on the cladding properties, general properties page, you've got the horizontal or vertical. But now we're going to go to the upper right. And instead of saying it's all in one line, I'm going to say level according to slope. And you can see there it's cutting the sheets off square, but at different heights according to the slope. You can do that as 1 sheet at a time, or 2 sheets at a time, 3 sheets, or even 4 sheets at a time. So there you go, that's 3 sheets at a time. Go back to 1 by 1. But if you want it exact, then you change that to cut along the slope on that option. And now it's cutting perfectly to my outline. So it depends on what effect you want with your cladding. Sometimes you just want it cheap and straight and jagged, and that's fine. Other times you want it a bit more elegant. So to get the door at the bottom, I've got to say cut along the slope as well. And now it's going to follow the exact shape, including the door at the bottom. If you have a look at the ends, then try and get a nice angle for you here. You can see the ends are overlapping, and if I choose different types of section, you can see the shapes. How the different ones overlap or meet up along the edges. Try and find one that's a thick insulated panel. Never quite see the right one in the list, and I'm looking. There you go. That'll do. So thick insulated panels, that's probably not really all solid steel, is it? That's going to be thin layers of steel with insulation in the middle, but it's just modelled as one thick panel. But look at the complicated shape of the overlap there. So the interlock is modelled on the side edges of the profile shapes, and the macro does the clever bit of laying these out next to each other so the interlocks fit nicely together. So that's one of the main functions of this macro. So there are a couple of things to remember when you're looking at this. So let's check those out. Supporting beam. Once again, if you say no to supporting beams, then your sheets will be an infinite length. So you could have 6, 7, 8, 10 meter sheets. If you prefer to keep them manageable, you can say yes to supporting beams. You select your supporting beam, such as a side rail or a cold roll purlin, and the length of the sheet is split and overlaps on that supporting beam. The idea being that you bolt through both sheets into the supporting beam. Or if they're a thick composite panel, you could then say that the overlap is 0 on the overlaps page in the properties, and they will meet end to end on the system line of the supporting beam. So you can make it automatically clip the lengths of the beams at the right points. Another thing to think about is the first edge of your area. If you look at my right hand picture here, the cladding area comes right to where the white line is showing. So that was where I defined my area, and the first cladding sheet is starting there, and you can see you've got the interlock is within that cladding area because it uses the whole width of the sheet. In the options in the dialog box, you have a choice whether it's the left is a first full sheet, the right is the first full sheet, or the middle is a full sheet and both edges are trimmed. If you're using left or right, you might want to consider or remember that you get the overlap, the interlock on that edge. And if you wanted a smooth edge, depending on the type of panel, maybe you trim off that edge, then you might need to say, if cladding should have started where the red line is, I'm going to have to extend my area by however much, 20 mil or something beyond where I really want it, so then I can put a rectangular contour to trim off that edge or something like that. But remember that exposed interlocking edge will be included within your cladding area, unless you're using the middle option for the middle full sheet, but then that's only appropriate if you can trim your panel right up the middle of it. So just have a thought about that. Within the system, there's a range of cladding sheets. They're quite old. They haven't been changed in 10 years or more. I don't know if they're still available. I'm not familiar with the suppliers available readily. But there's a good chance the one you want isn't going to be in the system. And maybe you'd like to add that. You can. It's quite easy once you know what to do. But there are definitely some things you need to know. So first of all, you define your new cladding sheet as a user section. These cladding sheets are basically really complicated beams. So they're fancy beam sections. You define it as a user section. When you're defining your user section, I would recommend you define the simple or the standard outer contour as a very simple shape, just using a smooth front and back like a rectangle. You can see I've done that in green here on my example image. Then I would define an exact outer contour with all the rippling and fancy shapes going. You need the interlock on both versions, but all these bumpy, fancy profiles you get on the front shapes, I would save that for the exact contour. Whenever you define a user profile or user section, you should normally define 9 points where the system line can sit on that profile. And that is good practice to do that, and you should definitely do that on most of your beams. But actually, bizarrely, I find for cladding, it always seems to get a bit confused whenever I define these 9 points. I never quite get what I expect. But if I leave none of the points on the system, leave them all off completely, so there's no reference points defined here, the system works it out for itself, and the system seems to get it right. You might not be able to place each beam manually using all the different 9 points, but why would you ever place one of these sheets manually? You'd only be able to use the system, the center of gravity. But the system works it all out and interlocks them correctly if you leave off the 9 reference points. So let's have a quick look. Here's my drawing. You can go to the extended modeling ribbon and you've got the panel for user sections. Here's the tools that changes it to the right layer. It's all about drawing the right shape on the right layer. So here's my standard outline. This is very simple, just a flat front. It still includes the interlock, otherwise you'd get clashes on your model. And this is going to be 600 wide. You can see the name is Alex 600. So the 600 is from the edge of one interlock to where the next interlock would be, so bottom there. that measures the 600. It wouldn't be 600 across both interlocks because then you'd only end up with 580 working width. So you have to draw it all the right size. Hopefully you can find a 2D outline from your supplier. You need a type name text and you need a section name text, as always with all user sections. It's important to know which is which. The dark blue is a type name text, the light blue is a section name. Once you've drawn it, you hit the generate all sections button and it adds that section into your system. So now my system knows what an Alex Panels Alex 600W beam is. That's just a beam. I can't use it with the cladding yet. I've only defined it as a beam. So there's more steps for defining this as cladding. This is where people probably get confused, because the next step is to start adding things into databases. All a bit scary, the databases. There's 16 different databases with thousands of lines in each. So you have to do this carefully. So this is what you add. You go to Management Tools and use the Table Editor function. And you click on the top left, Open Installed Databases. That'll bring up something like this. You find the table in Asta Rules called Rule Cladding Profile Classes. That's showing here. You go to the bottom and you add a new line for your section. And you've got 4 columns to think about. The first column is the key. That's just any number that's not already used, so the next available number. The class is the critical one. This is what you must get right every time. And the name here, you could go looking it up in other tables or whatever, but unless you've done something fancy, the name will always be capital U, small SR space, plus whatever you put on the dark blue text on your user section. So in my case, user space Alex Panels. Never include punctuation in your section names. And that wouldn't be Alec apostrophe S, it's just Alex. I have to live without the apostrophe. This isn't an English grammar exam. This is a computer database. The URL column, if you were using a common supplier like Metsec, then or Kingspan, you could put a link to their homepage in that column. Just a simple web address, as you can see above, for their homepage. Logo index or logo IDX, unless you've got fancy code in DLLs with images embedded in them, just leave that as -1 like all the others and you'll get the generic image, and that's perfectly good. Then there's a second table you have to add stuff to. So the third step after adding the range of cladding into the first table, you've got to add each individual section. So again, you go into the table editor, open install databases, still in Asta Rules. This time you go to the next table down, Rule Cladding Profiles Info. So you had profile classes, that was the range. Now it's each individual profiles info. Again, you go to the bottom and add a new line. And again, there's 4 columns. The first column is a key. You can use any number that's not already used. The class is very cryptic. That will be the type name text exactly as we put in the previous table. So USR space, whatever you put in dark blue, plus these squiggles, hash at section at hash. Easiest to copy that from another line. It's very hard to type the section symbol. You need to know a character code. So just copy and paste that from another line. And then whatever you put in the light blue text in your user section, which is the section name, goes next. And that all strings together, so you can see a long string here. The working width often gets confusing. If you try and work out what they're talking about on previous beams, I find that very confusing and I can't make sense of it. But basically, this is the distance from the leading edge of one sheet to the leading edge of the next sheet, or you could say the center line of one sheet to the center line of the next sheet, when they're properly installed and interlocked together. So it's not the full width of the sheet, because that's always a bit more because it's got the interlock that overlaps. So it's the distance between the sheets after they interlock together. And although all the other lines in the system out of the box have different values in the 2 columns, you can just put the step width and the working width as the same value. If you do that, everything works fine. I've not found any reason to have those as different numbers or what effect that would have. So there's no need to mess about. So give you an example. I have my panel. I called it Alex Panels Alex 600W. The complicated shape, once it's in the model, if I change the display in the model to exact, you can see here it's showing the full complicated shape. So it's not the exact shape will be nice when you want to see it looking pretty and fancy, but most of the time you don't need that level of detail. So that's why we have the simplified shape, and I'll show you more in the drawings. But going into the tables, into the database standard for, as we said, the class in the profile classes thing will be USR space Alex space panels, because I've got Alex space panels there, and exactly match what I've typed. Then in the profiles info table, you can put the section name again, USR space Alex panels hash at section at hash, and then whatever I got in light blue, so Alex 600W. And the working width, you can see here, I'm trying to show it to you from the edge of the one beam to the edge of the next beam, 600. So that's the working width and the standard width, or step width columns. And this is what that same profile looks like in the standard presentation. So it's nice and simple and flat. You don't need to see all these ripples all the time. Be very careful to make sure you include exactly the same capital letters and small letters and spaces. The syntax is critical. Any error will mean it just doesn't find your beam and doesn't work. So you have to be exactly matching the right punctuation, the right letter case and symbols and spaces. Go into management tools. Right, so it's table editor. And then the first icon in there is open installed databases. And you get the 12, 16 databases showing. You've got to find the right table. So easiest thing to do is come down to the use filter here, and both the tables you need to have the word cladding in them. So start typing cladding in there, and it only shows tables listing with the word cladding in them. So now it's easy to find the ones I want. So profile classes is the first one. So go to last, and what I've done, I've added in there an available number, the exact thing. So my panel was called Alex Panels. So literally it's capital USR space, and then Alex space panels with a capital A and P, exactly as I had it written. Don't need anything in the URL, but I could put simple sort of graitec.co.uk or something if I wanted to in there, and then the -1 for the logo. On the next page, I have to do each individual section. So if I had 8 sections in my range of Alex panels, I'd have to add 8 lines in here, one for each section's size. And again, the first column is just the next available number. Then it's that same type name, those 5 squiggles, hash at section at hash, which I can just, if I click in here carefully, I can then highlight the bits I need, copy, Control C, and then go into the new line and Control V to paste. And then whatever I wrote in light blue, Alex 600W. And again, the working width and step width, I just use the same value every time for both columns, and that's the distance between the sheets, that's 600 each way. So they're not that confusing to do once you know what to do, but it has to be done, and has to be done properly. So how about generating drawings? Once you've got your user section in there, you can just use that in the cladding macro as normal, like any other section. It will always place it in the standard presentation mode, so it'll always just come in with the flush flat front panel. You can change it to the exact presentation mode if you wish for your pretty pictures, but it won't show on the drawings. Let's have a look at the drawings. First of all, let's think about GA drawings. Nearly all drawing styles will not show the cladding. So that's a 3D view of the entire model that I created. The model still had the cladding on there. You saw that on the video earlier with the decking and the front panel, not showing any of it. Because if you show it, you can't see much else in the structure. There's only one style in the UK build, don't know about other countries, but in the UK build, there's only one GA style that will include the cladding, and that's very clear, and its name is called cladding arrangement drawing. So nice and obvious. That shows the cladding like you can see on the right hand side here. Now, I've said a few times, have a simplified presentation. Notice how complicated this is, and dozens of lines. Each ripple and dent and kink in those sheets is being drawn as a solid outline. So if you try and print that, and these are all printed nice and thick, it's going to be sort of a solid black area if you're not careful. On screen you can get away with it, but on printing it doesn't look so good. If you define your cladding using a simplified or standard outer contour that's nice and straight and flat, you get a drawing more like the right-hand one. So the decking is still the normal out-of-the-box profile. The front profile I've changed to the Alex cladding, which is the simplified standard profile. You can see that's cladding sheets, but you're going to get much less drawing work on there, a lot less lines. It's much clearer and easier to understand. You don't really need to see these ripples for every single ridge. It's not helping or really improving very much. In fact, if you do a simplified standard contour, you will always only get the simplified version on the drawings. Because out of the box, none of the drawings will show the exact outline. When it comes to part drawings, you can actually produce part drawings for each unique cladding sheet. So after you do the numbering, they'll all be numbered CL 1001, 1002, 1003, or whatever. But when you do that, you can see obviously the sheet has all these different ridges in it. Unfortunately, when it draws that sheet, it dimensions all those ridges because they all count as visible edges, which is a bit annoying and a bit messy. This is actually quite a simple sheet. A lot of the sheets have a lot more ridges and shapes in there, and you get lots and lots in this dimension, which makes this dimension useless. So again, this is why a simplified front face can help a lot. Because when you have it with a simplified front face, there's no complex extra ridges. You get the dimensions for the interlocking bit, but you just get a flat front, and there's the cross section. Like I say though, this is a slight hiccup because it always shows the smooth or simple section on the drawings. Out of the box, there's nothing that will show the exact section on this drawing. So it might, I can understand, it might get a little bit confusing on a sheet like this, which one's the top face, which one's the bottom face. Most sheets, the bottom interlock and the top interlock are actually different, so it might be quite obvious. But if those are sort of, this one looks like I could turn it over and it would be the same either way. But of course it's important to get the right front, so that is a slight hiccup. You might have to think about that. But that's a neater drawing because it's only dimensioning the cutouts, not all the irrelevant ridges that are already made. We can customize the drawing style so that it will show the exact contour in the right hand view if you wanted to do that. That is under customization, or if you know how to edit drawing styles yourself, you can try and tackle that yourself. It doesn't matter whether you're showing exact or standard in the model, it will still show standard on the drawings. Like I say, you have to edit the drawing styles to change that. Okay, so we have a few moments if anybody wants to ask any questions. I hope that came out clear. I apologise for the problems with the video. If you have a question, please type it into the questions panel on the right hand side. Don't forget to download the handout, because then all the links to the other resources that I've stated at the start, they will all be live links and you can click on them. This particular webinar will be recorded and posted on the Content Centre within the next few days. So if you want to review it again, have another look on the Content Centre in a few days' time. So I hope you found that interesting and useful. The cladding system is very simple once you get to grips with the basic things. So openings, you've got to remember, after you say what shape you want, rectangle or polyline, you have to pick the existing cladding area outline and then go and pick your openings. It's not the sequence you would expect there, but they work fine when you do that. You can't have curves on the cladding shapes, the outline or the openings, and they have to be straight line shapes. The options in the box are fairly easy. You probably need to set it to cut along slope to get the exact shape, otherwise you're going to get the jagged edges. And you can define your own profiles with creating any user section. If you leave off the reference points, it seems to work better. And we discussed or showed how to enter the right entries in the database for each section. Once you've got the right entries in there, you can use the table editor, it's easy enough. then you can just call up your own sections in the cladding macro from then on. Okay, thanks very much, everybody. That concludes our webinar today. I hope it was interesting and useful.